I welcome you to my another video about electronics. Today, more worldwide, like for almost everyone. Some of you may know my channel Bekr Technologies and some may even know my main legacy channel that is in Czech language. But most of you are new here, so that was just a quick introduction. Now, what did I test? I tested every battery of every available type I could get. Zinc carbon, zinc chloride, alkaline, primary lithium or non-rechargeable lithium, then come rechargeables, ranging from nickel metal hydride through nickel zinc up to lithium ion made for 1.5 volts output. Then we will talk about every one chemistry type separately. Then we will talk about every one chemistry type separately, just some quick info and useful tips, and then we will pick the best ones in categories. We, however, will not compare between chemistries, as one can't directly compare, let's say, zinc carbon to nickel metal hydride. What do you see here is polystyrene or styrofoam box full of alkaline batteries and some lithium and zinc carbon ones. These are non-rechargeable batteries and there are exactly 10 kilograms of them. This is all the batteries I have discharged, but only the non-rechargeable ones. This is the most extensive and most precise test you have ever seen, you can ever find, or one has ever done. Can you see the bottom of this? No. This is the biggest test ever. Why these claims? Well, regarding this topic about best batteries, there are only half-truths, bad tests and narrow tests. Half-truth? One television has done tests of batteries, as they call it, and instead of focusing on laboratory data, and they had them available, they kept asking random street people about batteries. Useless. That's really useless. Bad tests involve buying, for example, smart charger and best capacity wins. And narrow tests usually test like fun or flashlight runtime and up to 10 batteries maybe. That's the most I have ever seen. People need to know what's the most economic battery type and brand for their use. And this need grows if you have like audio instruments, measure and data acquire instruments, or even run a company. We need it, but no one has ever done something about it until now. My test not only involves capacities but also internal resistances and calculated metrics from them. And it is not even limited to this dense video, as there are more tests regarding this currently running. It takes determination, knowledge and will to help people. People like families with lots of toys, or music bands with their battery-powered microphones and combos and such, or someone like me who has dozens of batteries and multimeters, environmentometers and such. Before we jump on batteries and the data, let's first explain calculations regarding rechargeable battery economy and regarding the table and how to interpret their data. Rechargeable economy. Let's have two examples and then deductions. First example is very subjective. I run a week-long event once a year, and if I used non-rechargeable batteries like these, like alkaline Duracells for example, to take something into calculations, Duracells are available everywhere. I would spend $77 just on batteries for the week. However, if I used rechargeables, then even with calculated life of just 10 years and strict amortization of charger, I would hit maximum of $4 per week. Let's get more serious. Some people shout nonsense like rechargeables are not worth the money as one can buy 4 alkaline for them and such, but this is nonsense. So let's jump into calculations. Let's assume we have a device that runs on 4 batteries simultaneously. The most available batteries are, for example, Varta Long Life Power. These are good alkalines for 75 cents each. They provide 1 amp hour if discharged with constant 1 ampere current. easy numbers for us. Second alternative is rechargeable, but the same brand. Varta Power costs $3 each and provides us with 2 amp hours at 1 ampere load. My investment must include also charger. Let's say $22 for good Litokala LII 500. I have 12 of them, by the way. So 4 rechargeables and charger cost me $35. Stupid one would spit, heck, I won't buy anything this expensive. I would rather spend it in fast food. Smarter ones start calculating. Even if we had to buy a new charger, the rechargeable investment would become more economic after a 6th cycle of the rechargeable batteries. Charge them for the 6th time and you are cheaper than Alkaline. And this goes even further, as many of you already own a charger, so there would be no need to buy one, and you are cheaper even after third recharge. Let's advance in future. Such good quality battery like Varta Power would last, let's assume, 1000 cycles. I am currently running tests on that, by the way. So, as I cycled the rechargeable batteries 1000 times, I would otherwise, if I used non-rechargeable ones, have to buy 1000 cycles times 2 times lower capacity times 4 batteries in set. That would equal 8,000 pieces of alkalines per lifetime of 4 pieces of rechargeables. That makes $6,000 for non-rechargeables. $6,000 spent on batteries, alkaline batteries, during lifetime of just 4 rechargeables and their charger. $35 for rechargeable solution versus $6,000 for non-rechargeable. That is long-term effect, my friends. So where is the borderline practically? Well, to generalize that, if you have to change batteries in something once a year or more often, you would be better with rechargeables. This table is from my older test. It was 60 types of batteries. Now we are at approximately 200. First is price, that is in Czech koruna, CZK, CZK. To get dollars, divide this value by 22.6, and to get euros, divided by 24.5. Actually, you shouldn't need to do this, as all the metrics that are related to price tell you the economic worthiness of the battery regardless of used currency, as the cheapest will always be cheapest and the greenest, etc. Then comes name, second name or node, principle of chemistry, nominal capacity, and expiration date. Since nickel metal hydride batteries have no expiration, I wrote down their series. Then comes colors. These colored cells are results and calculated metrics. First column is internal resistance, measured with DC method of 1 ampere at 100% capacity. Resistance is only comparable between same chemistries and not different ones. Why so? Internal resistance is voltage drop on battery terminals once current begins being drawn. Actually, for 1 ampere, the milliohms represent millivolts of voltage drop. That's why I chose this current, it makes things simple. Let's take, for example, zinc carbon Varta Superlife. That has 381 milliohms. Its no-load output voltage is about 1.65 volts minus 381 millivolts is approximately 1.27 volt. Also, GP Lithium has same resistance, almost the same, of 388 milliohms, but its no-load voltage is higher, 1.85 volts. That makes 1.47 volts under load. So even if this battery has same internal resistance, its actual voltage under these same conditions would be 0.2 volts higher than this one. That's why we can't compare between chemistries with different no-load voltage. Next, 4 columns are capacities. Capacity was measured with constant current of 100 milliamps to 1 ampere. The cutoff voltage was 0.7 volts, as some experienced electricians would assume the capacity drop with higher current drain is caused by internal resistance. Not only the internal resistance lowers the output voltage, so cutoff event comes sooner than the battery gets fully discharged, but it also wastes the energy of the battery to produce heat. Exactly same phenomenon on wires. If you choose thin wire for high current, it will get hot and cause voltage drop and power loss. Same with batteries. So the higher the actual internal resistance is, the more significant difference between capacities. It may, however, not always go in hand. Those are the cases when the battery internal resistance changes a lot during discharge procedure. My internal resistance measurement was done at 100% of capacity, and this value more or less differs from internal resistance of the battery when it is on 50% of capacity, let's say. Next comes price divided by capacity for low and high current. Actual price to life ratio. Most people are interested in this. For power-hungry devices, look at 1 ampere column, while for low drain devices, the 100 milliamp column is yours. Next comes currents approximations. This old table had different metric, but somewhere here we have currents approximations. Imax is the current we can peak drain from the battery. It tells us about the maximum peak current capability, not nominal. It is calculated from voltage drop to 1 volt and internal resistance. Nom is nominal current. It would be my guess for nominal long-term current drain to keep at least some of the capacity useful. And the last one is something like average of the price to capacity ratio globally. So let's finally go through different battery chemistries and show their tables with results. Zinc, carbon, and zinc chloride batteries are our heavy-duty or super heavy-duty cells, a long time ago commonly called dry cells. They are lightweight, they are dirt cheap, but their capacity and internal resistance are the worst. Approximately 800 mAh for low currents and approximately 150 mAh for higher currents. As you would guess, this difference would be caused by resistance. And yes, they have enormous around 400 milliohms of resistance. They are only suitable for lowest current drain devices where they would provide power for many years, like for example wall clock or remote control. The best of this type are Tesco branded ones. They are also encapsulated in plastic case with outer steel shielding, so they won't tend to oxidize outside, and their lifetime should be some tens of years. At least I hope so. If you aren't situated in Europe, you may also grab Kodak Extra Heavy Duty. I don't have that one here, unfortunately. My bad. Oh, I found it. Yes, this one. So if you aren't in Europe, buy this Kodak Extra Heavy Duty for low currents. Alkaline batteries represent the most selling ones. While most of their applications, it would be more economic to use rechargeables instead. Alkalines are, however, quite wide-use cells. They have around 2300 mAh for low currents and around 1000 mAh for higher currents. Their resistance is therefore somewhere around 170 milliohms. They are better than zinc carbon batteries in every aspect apart from price and longevity. Their price is approximately 3 to 5 times higher. Here we have discharge characteristics of alkaline battery. Notice that at 1.0 volt it still has 50% of remaining capacity, while some batch products may cut off at just this voltage. The sharper the transient to the final drop, the more constant the voltage is, and the more % of energy can be potentially drained from a cell. However, alkalines have too big radius. Alkalines usually hold up to 10 years, some less, some more. Generally, Billa Clever and GP alkalines always leak, even if they are fully charged, they just leak prematurely. I am currently running tests of recharging these alkalines batteries, and I have quite the results. Alkalines are good for medium power devices that are used just rarely or occasionally. About their results, if all you need is high current capability, then go for Panasonic Everyday GP Ultra Plus or Duracell Ultra or Lidl Aerocell. If you care about high drain actual capacity, choose Aerocell from Lidl or Duracell Optimum from Amazon or Golden Alza Power from Czech Republic or Philips Blue Gold one. If it is low current capacity you want, then Philips Premium Alkaline are the best. Then comes Tesla Gold and Rossmann Rubin. The best price to overall volume ratio can be reached with Pepco But Extra, Amazon Basics and Lidl Aerocell. Primary lithium cells are non-rechargeable ones with awfully high price tag. They actually cost more or the same as rechargeable cells, but they bring excellent capacity and high voltage to the table. Their capacity goes around 3000 mAh for higher currents and 3500 mAh for lower currents, and their no-load voltage is around 1.7 to 1.8 volts. Their lifetime is longer than 10 years, thanks to the enormous capacity and longevity and also high price. The only reasonable use for them would be in things such as CO2 detectors, safety photo traps or any other appliances that belong to safety long-term vaulters. For primary lithium, the best is Energizer Ultimate. Period. One of the cheaper ones, but it wins with its capacity by quite much. Energizer Ultimate is ultimately the ultimate winner. Nickel metal hydride batteries can be bought for $1 to $4. Their capacity goes around 2400 mAh for low currents or 2200 mAh for higher currents. These capacities are very close, right? Could internal resistance be involved in this, you ask? Of course it is, because they average around 60 milliohms. That is very nice, but things may get worse. This is discharge curve. It may hold the voltage for a long time, but look at y-axis. 1.1 to 1.3 volts. Thanks to the quite constant voltage discharge curve, one can easily design an appliance that would operate at best efficiency at exactly these voltages, respectively multiple times this voltage, of course. However, it may be ignorance, cost cutting, or just plain will to earn more, that there are still many manufacturers out there who produce appliances that would reject to work at such small voltages. So you need to keep buying pellets of alkalines, right? Well, there are two alternatives for nickel metal hydride. We will talk about them in few minutes. We have plenty of nickel metal hydride cells in this test. Well, they costed me quite much, of course. If it is a high provided current, we need grab GP Recycle Charge 10 or GP Recycle Fast Flash is this one actually. Then it is Eneloop Pro, IKEA Lada 2450 and Hama 2400. If we need high capacity for our low drain appliance, Varta Power 2600 is the best. Then goes Ansman 2850, GP Recycle 2500, Conrad Endurance 2600 and Panasonic Senio 2700. The best price to capacity ratio is Lidl-Tronic, and for better quality cells, or if you aren't situated in Europe, IKEA Lada 1900. One more thing, Varta deserves applause. It has the biggest capacity of nickel battery, and all the Vartas seem to be of high quality, as preliminary data from cycle tests suggest. Of course, great quality is also achieved with Eneloops, but they are well known. Nickel metal hydride batteries, as they are rechargeable, they should last long, but that depends not only on the quality of the cell, but also how do you treat them. If you treat them right, they might hold more than 10 years. Speaking of Panasonic Sanyo cells, for example, they last usually 15 years or so. The base is good charger. It must end charging and DV event and also should monitor temperature. Really good chargers also monitor temp of each cell and trigger also the T event. Good charger lets us choose charging current. Other functions like capacity measurements or discharge or cycling is just for comfort. So we will have more in one solution. It's up to you if you have use for these functions, but definitely buy the one that has DV and DT. That's the base. After we buy the batteries, we must format them, so they form inside as they should be. This procedure increases their capacity to nominal value and strengthens their internal resistance. One has to fully charge them, then discharge and again charge, and repeat this usually 3 to 7 times. I usually do it 5 times. To store your nickel battery, fully charge them and recharge every half a year. If it happens to be stored for a long time, I would recommend to do the formatting process once you grab them and want to use them. But the layout should not be that damaged, so 2 or 3 cycles should do the trick. If you let them discharge for a long time, they may resist charging attempts. Also, many smart chargers would not detect them or reject them as defective. Resurrecting nickel cells is nothing difficult, and unlike lithium ion, you have high probability that the battery can be used for a long time on. Of course, the lifespan has been shortened with this torture, but it doesn't mean instant death. The nickel cells usually resist charging. If you have laboratory power supply, just like I have, then you may need to set it to 1.45 volts and current even as high as 5 amps to push them up. If you don't have the equipment, then just grab one fully charged battery and jump start the bad one. Needless to say that this jump start is utterly dangerous to do with lithium ion cells. It is only safe for nickel cells. Once you charge them, put them to charger as soon as possible and cycle them. As they may have been internally damaged, usually you need to cycle them up to 8 times to retrieve most of their capacity back, but they will never be like new. Nickel zinc. The alternative to nickel metal hydride is both better and worse at the same time. Remember the appliances that turn off at relatively high voltage? Those devices that reject rechargeable NiMH batteries and need steady supply of truckload of alkalines? Well, nickel zinc solves that. They have even higher voltage than alkalines. They peak about 1.8 volts per cell, and at 1.3 volts they are considered discharged. It can be said that where nickel zinc ends, the nickel metal hydride starts. Their nominal voltage tends to stay near 1.65 volts. Such high voltage per cell is great for devices that tend to turn off prematurely. However, there are also downsides. First of all, the capacity is lower. They usually have around 1500 mAh for low currents and 1100 mAh for higher currents. Their internal resistance is definitely acceptable, around 50 milliohms. Even if they have half the capacity as nickel metal hydrides, they store not that much different amount of energy. Such nickel zinc has 1.5 amp hour times 1.65 volts. It is 2.5 watt hours. They even write it here, 2500 milliwatt hours. So the stored energy is 2.5 watt hours. If we divide 2.5 watt hours by 1.2 for nickel metal hydride, then equal nickel metal hydride battery would have 2.1 amp hours. So this, for example, 1500 milliamp hours nickel zinc equals to 2.1 amp hour nickel metal hydride if we talk about stored energy. It is then still worse, but now at least not that much. Charging nickel zinc batteries is tricky for most folks, but for us electricians really easy. They need separate charger made for nickel zincs or universal charger that is compatible with nickel zincs. I happen to have this Chinese PK cell charger and it works quite okay, but the cells are connected in pairs, so nothing that great. But considering the price of any other nickel zinc chargers, you may go for this one if you need one. If you need to charge them in lab or want to build your own charger, it is very simple. Just use CC-CV power supply or converter, set CV to 1.85 volts and set CC approximately to 500 milliamps for AA and 250 milliamps for AAA. That's all. It's this simple. Regarding formatting, cycling as such, same rules apply as for nickel metal hydrides. Nickel zinc is quite a new technology and it hasn't spread almost at all. And it is a shame, because it could have already saved tons of alkaline battery waste. Chloride from Germany has really good nickel-zinc cells. They have beautiful internal resistance, so they are perfectly suitable for cameras and such. If we went after price, pocket cell from AliExpress ain't bad at all. It actually slays for the price. You can buy a few bucket cells for test to find out whether nickel zinc save your money by working okay in your power demanding device, and then invest in better Chloride ones. Or you can continue using the bucket cells. One more thing, these nickel zincs have unknown life expectancy. It is subject of my another test, where I cycle all batteries and look for capacity dropping after time, but the results will be available, let's hope, for this year. It is a Mars test that requires lots of resources. I am cycling 48 cells at the one time, and it still isn't enough. One black sheep, actually black, is Huntsman. Huntsman nickel zinc cell is not only not that good on paper and not only has it worse price, but one of them I have has died. It is the one I had for cycling test of lifetime. It just shorted, and as I resurrected it, it dropped capacity by so much it can be considered dead. Bad for Huntsman. We have gotten to the last principle, lithium ion cell and step-down converter inside of a AA battery chassis. We know lithium ion cells from notebooks, mobiles or power tools. They have near perfect internal resistance and triple to 10 times the stored energy compared to other common chemistries. However, the lithium ions have nominal voltage of 3.7 volts that would most probably damage your appliance if applied directly. Actually, lithium ion cells are also made in 14500 case that are exactly same as AA battery, but do not interchange them please. This Chloride battery has tiny lithium cell inside, then there is step-down converter that makes 1.5 volts that are sent to the tip. If you want to charge it, you just open the tip and boom, we have got USB. Just plug it in one of 16 of my computer USB ports and I am charging. It's as simple as that. Pretty convenient, but there are downsides. You must have realized how much space is wasted with this Type A USB male connector, and the missing space has been paid by capacity. The manufacturer had to fit step-down converter and charging circuit inside, and there is just a little space left for the lithium ion cell. That's why it has only 1 amp hour effectively. This space wasting is solved with smaller connector like this AliExpress lithium battery has. Even though the Chinese have saved some space, they decided not to increase capacity but to only use better step-down converter in this case. It may be more efficient and have lower voltage drop, but capacity is more or less still the same. These two batteries are very often rebranded. Wind of change blows with this Phoenix, that is professional headlamp brand. It has obsolete and not durable micro USB that may actually withstand lower amount of cycles than the lithium cell inside, but its capacity is 1600 mAh or milliamp hours. That is pretty competitive, isn't it? But what if we wanted to save even more space for the lithium cell inside and put out the charging circuitry alongside with USB connector? Now, the battery may require external charger, but it can fit even more of that lithium and nickel and cobalt and such inside. This results in Kentley having 2000 milliamp hours that also come with beautiful internal resistance. Beware, they write milliwatt hours divided by 1.5 volts, it's 2000 milliamp hours. They also have beautiful internal resistance as the step-down circuit inside has good current capabilities and good load regulation. These USB lithium batteries are, however, nothing but cheap. They are actually expensive as hell. The Kentley ones that I personally use, well, I began using them after these results came out of my lab, they cost $7 each. It may then represent alternative to other rechargeable batteries. They have stable output, for example, and Kentley also drops the voltage at 10% of remaining capacity so the device notifies you and doesn't die without any warning. But the price, well, that will depend on my ongoing test on cycle life, whether nickel zinc are really more economic than lithium ion with step downs. Final chapter. We have gotten to the very end of the video. These samples, these batteries I had to buy, I remind, these are not all of them. I had to buy them for my money. They costed me 1,127 US dollars, or for Europeans 1,042 euro. The test equipment took $310 or 290 euros. One could buy old car for that. This is the price I paid, so not only I, but all of you could switch to more economic and more suitable source of energy, and therefore save our money, our planet, and our nerves. If this video has helped you, you can help me produce more of this stuff. You can either like the video, so YouTube will offer it more frequently, and you can even share link to this video. You can also become channel member. These folks are the good people who support me periodically on my main channel. Currently, this English channel, Bekr's Technologies, doesn't have allowance for members. So you can, if you want to support me, go to my main Czech channel and become member there. The tables are available in PNG in full resolution under this video in the description. Please note that since this test has took me good few months of my young life, I have written copyright to protect what have I achieved. So I hope you took something good from this video and that you will put your gained knowledge in use. Well, that's all for this video. Goodbye and see you in another video.